My name is Carson Lang. I'm with OptaSense. I'm here to help the U of C set up their interrogator unit at the CAMI site. We'll be plugging into the fiber optic cable that goes into the multi-wells, and we'll be acquiring a VSP on the walkway lines and walkabout. The system settings we'll be going through are the similar setup process as we did at the University of Calgary, with a little bit of a slight variance to the acquisition we'll be acquiring today. What we want to do first, we know the fiber is good, but you guys will always want to, when you go to any site or connect to any fiber, check the OTDR first before you connect to the cable. Most times you'll know, once you come to site here, you'll know that it hasn't broken or anything. But usually it's really good because the OTDR, it's a quick check to see if anything has broke outside, maybe at the wellhead. You can check the distances, and that can save you some time. Instead of getting to the unit, you'll see you're shorter, and then you're going to have to troubleshoot it anyways. But if you're going to a site you're not familiar with, the OTDR will allow you to see whether it's broken or if there are large reflections and what to expect when you go to set up the IU. So we'll just power this on. This is our unit, but it'll be very similar to your guys' model. You just have the newer one again. So we want to clean this cable first, or this connector. Again, what I do is just have either your alcohol pad, or you may have the alcohol wipes with the actual liquid alcohol. But you just want to pull this this connector lid back. If you have one of those red clips, it makes it a little easier to pull it down. And all you want to do is just dab it and not pull it across the face. Take your top cleaner, and then you'll just want to just clean the front of this. So there will be two connections for the OTDR. One is multi-mode and one is single mode. So you're using a single mode cable, so you want to, on the start screen of your OTDR, you'll see there's different options for single mode and or multi-mode. Try to angle it here for you guys. So it'll say down here, you can select between them. It usually goes to the last setting you're on. So when you're okay, you just go to standard OTDR. And again, just to go through some of the settings, I believe this is 5,000 meters, this fiber optic cable. So you'll just want to adjust your distance and range of what you want to be acquiring the OTDR at based on the fiber. So this one's 5,000, so we're just going to go to 10 just to go past the fiber. And then with your length, you'll also want to look at the pulse width again. And the best rule of thumb is to go to the smallest pulse width you can, because that gives you the better resolution on the fiber. So that's good. And then another setting you will want to make sure you have on is the averaging time. 1 minute is good enough to collect that trace. So you select the time you'd like to take it, and then once you're ready, you just say manual test. So we can see the trace is populating already. It'll just take a minute here to collect the entire thing. But while it's collecting, you can zoom in and out and kind of look at what's there. So you'll see this front end is our spool we have inside here is just the buffer cable, but then you can see we connect, and then you can see the multiple connections do denoted by the drop on the cable here. I'll try to zoom in. So these will be the different splices you guys have, whether they're right into the wellhead, loops back out, another splice, and you can see that there's some drops here. But it looks really good. So it finished collecting, and I'll just save this trace. So looks good. If there is an end reflection, like I said, you will want to try and mitigate it, and that's either by splicing on or putting on one of the end reflection attenuators, or if you do have access to it, you want to be very careful. But there is a slight trick where if you use one of these bulkhead connectors that usually connect to these E2000s together, you can just open up the one side, and if you leave the other side closed, and since we know this is the end of the fiber, if you plug this in, this will actually get rid of, and just keep this side closed so the laser isn't coming out on that side. But what it will do is it'll get rid of the end reflection for you. So I'll just quickly run it again and just check the end. So I don't know if you noticed, but at the very back side here, there was a bit of a spike, and now that spike is completely gone. There's just a little thing, but that's fine. And if you can't, if this trick doesn't work and there's still an end reflection, you can go into the software and use the blanking function to get rid of it. But this is the most critical thing. If any large reflections are here, it will damage the photo detector over time. This is good. So I'll just power this down. So we know the fiber is good. We don't have to fix it. Your connectors should always be clean, but what I like to do is anytime I go to make a new connection, I just like to give it a clean again. You might have dropped it or something, so I just go through the same process, use a new side of the wipe. And then I just clean it again before I put it into the IU. So now on the back of the IU, you'll see something very similar to this connector here, this bulkhead. And all you want to do on the back of the unit is there is this latch here that when you put it in, you can push it up, but you don't have to do that to seat it. All you do is on the back of the IU, you just take the E2000 and just plug it straight in, and you can leave it and it's good to go. And then when you leave site, you can do the same thing. Just it sticks a little, but you just give it a little pull right on here. Try not to pull on this yellow jacket, as it's a little bit weaker here and it can start to pull away from the E2000 connector. And then all you have to do is just replace the head here if that comes. So all I'll do is I'll just connect this now to the IU. When you lay out the fiber optics, wherever it is on site or stuff, the best is to have large loops. You want to, if it's hanging, this is fine like this, but you want to avoid like really tight kind of bends in the fiber, because it will also attenuate the light as well when you're setting it up. So you want to try to make the run as flat and smooth as possible. And also, this is nice in here, but also if you're out in the field or somewhere else, just try to protect that splice too, because even though it has the jacket on it, it can pull away. And having to resplice multiple times is never fun, so. Oops. It's plugged in. Just make some space. So now everything's powered on and connected. On the desktop, there's this folder. It says ODH 5.62. This is the software you'll want to run to acquire the data. So once it's loaded, on the top left hand side of the bar up here, you'll go to this OptaSense, this one called Data Sources, and then in the drop down is Optical Setup. And when you click that, the first thing here will be a connection button. So the IP address is in already, everything will be remembered. You just say connect, and it's going to talk to the IU. So connection has been established. Next thing, you'll see it says waiting for laser interlock. So now we know that there's no reflections and all that. We can just come down and turn our laser on. And then what the software is going to do is just wait for that laser emission, and it's going to do pulse balancing on the laser itself. It's just going to kind of get the pulses ready for the settings we're going to be choosing here. So this starting part with the laser emission will take a little bit here. So it's going to shape those pulses to the initial setting it has. And depending on the settings you're going to do, unfortunately you're going to have to do it twice, because once you change the way the pulses are structured or how fast you're pinging, the system's going to have to go through and do it again. But the second time usually doesn't take as long. We're going to ping the fiber at 20 kilohertz, and then we're going to decimate by 5 on the IU. And that decimation is just for data rates to send it across to acquire it. And then we collected 1,000 hertz for 1 millisecond data. So what we'll do is we'll go into the software, and there's a little bit of a piece that's a little different than I didn't show you at the university there. But for Seismic Acquisitions, it allows you to decimate further down to that 1 millisecond data set. And I'll show you a setting. We won't do it today. We're going to acquire all 1 meter channels on the fiber. But if the fiber you are interrogating, you don't require 1 meter channels, the software will actually allow you to stack channels. But for purposes, we were just collecting 1 meter data, that if you guys wanted to stack on your own that later, that was possible. Okay, so the lasers have balanced. Like I said, so there's a ping rate, and the ping rate is going to be dependent on the fiber length. I think the equation is in the manual, but around 5,000 meters, you're good to ping at 20 kilohertz. The longer the fiber gets, the lower you're going to have to reduce that ping rate. And the whole reason for that too is because where the system's waiting for the back reflected light, the further it is, the longer you're going to have to wait for that last bit of light to come from the end of the fiber before it sends its next pulse. So that's why it's dependent on the fiber length. But for us, this is good, so we're going to keep it at 20 kilohertz. But the other thing that I adjusted here was the gauge length. So that's the distance between the two pulses. It auto defaults to 7 meters, and that could be fine for the type of work you're doing. But last time we went down to a 4-meter gauge length. So that's just like your sensor traveling down the fiber. So when I go to 4 meters here on this acquisition setup side and I press set, this is where these settings control the lasers. So it's going to go back and redo the launch attenuation again. But the other thing too is you'll have to look at the data as well, because the smaller the gauge length, the higher resolution, but you're also putting in less light into the fiber. So you'll notice that at the further distances on the waterfall data or even your seismic data, you'll see channel fading because it can't get enough light at that length. So it'll just look like bad data essentially. So you'll have to just keep in mind and look at the data that you might have to up your pulse width. We've done testing on various lengths and 2 meters can be achieved if the fiber is not attenuated a lot as well. If it's a pretty new fiber, at 5,000 meters you could do a 2-meter gauge length pretty easily. But if there's a lot of losses and it's an older fiber with a high loss, that's going to affect the light too. So okay, so we're set up for how we kind of want to acquire it with the laser. Now the next is just the stream. So the data type you guys will be using pretty much for all of your acquisitions is going to be this data type 37, and it's called wavelength stack output channel pitch 1, and then it says DC, so there's no low cut filter, it goes right down to DC. So this data type, well, this is 1037, but data type 37 is what you want to use. But before we go into this actual acquisition setting, we need to attenuate the laser itself. So under stream setup here, you'll see there's this stream 1, 2, and 3. You want to click this and activate stream 3. You'll want to say read. And you'll notice when you say read, this enable checkbox here right beside the stream is unchecked, so you'll want to check that. And then for your data type, this is just only for the optical setup, is this, it's called scope data or scope mode, and this lets us adjust the attenuation of the lasers. And that's only for this stream 3 setup. So when you have that selected, you just say set. Just make sure stream 3 is enabled with the checkbox. Number of channels, you don't have to worry about entering it in now, but you could put in just for a starter like 100 channels. Say set. Then you have to come back to your connection tab and you have to disconnect. And then on this connection, you want to connect to that stream 3. So you want to go to control stream 3 in the drop down. When you click that, you just have to say reconnect. And it's going to connect to that. So the step's a little awkward, but you'll get used to it. And this is all in the manual as well. But this is just to enter into the optical setup. So now that it's reconnected, you can come down onto that side tab, or does that help? Can you guys see it a bit better there? So on the left hand side is configure attenuators. So this is where we want to see the laser power, adjust the power to the fiber optic cable and then the other detectors. So I'm just going to pull this down to give us some space. So by default, the system to protect itself, the launch is the power, the amount of power from the laser going down. It's low, but they set all of the detectors at a very high setting, a high attenuation, so that if there is an end reflection or a reflection somewhere, it doesn't automatically destroy the unit. So it's just a safety feature. Now in these steps, what you want to do is we want to put as much light as we can into the fiber optic cable without hitting that non-linearity mode. But this launch attenuation is too low for this type of fiber length, and you'll see on fiber lengths of where that non-linearity occurs. So what I do is for my launch, this is the power of the laser, I bring it up to 20 and just hit enter. And what we have to do is go through each of the 4 lasers and adjust the setting. But I start off with the first laser first. And here, this is where you can come back to your channels now. You go to Configure Acquisition, and we want to see all of the fiber now. So also, I don't know why they programmed it this way, but when you're in scope mode, the channel numbers change now. Just part of the programming of this, but it's a factor of 8. So here I put in 625, which is roughly 5,000, but you'll see it says 5,000 channels inside this. It's a little odd, but so you want to try to see your entire fiber. And then what I do is to see the amplitudes more clear, what I do right away is without adjusting the launch power, because I don't want to come into that non-linearity before I know, what I do is I bring down the detect and I exaggerate it a lot just so I can see it. So it defaults it to 31 here. I'm going to enter in something like 15 just until I can start seeing these amplitudes. You might have to bring it back a bit, but so here I had to bring it down to 2, but as I start bringing down the power, we'll be able to see. So I can see the amplitudes, and I can actually zoom in as well. So if you just left click and then you drag, you can zoom into the amplitudes to see them a little easier. And what you want to try to do as well is, if you can, to put your window a little bit past the end so that you know that you're at the end of the fiber and you're acquiring everything that you want. So here are my amplitudes. So now all I do is I bring down the power. Like I said, we want to get as much power as we can before we see non-linearity. And the effect you're going to see is that as you bring the power down, you increase power, you bring the attenuation down, all your amplitudes should increase linearly. And then when you hit the non-linearity, you'll see it will affect the end channels the most, or first, and it'll work its way up, but the amplitudes will actually start to decrease as you're putting more power in. And that is the indicator of non-linearity. So I just hit the, there's this triple arrow, so it's a larger decrease. So what I want to do is just find that right away. I'm just going to zoom in a bit more to the end so it's a little bit more obvious. So there, it looks like it all went up. That looked fine. And you may want to zoom out as your amplitudes come up. You just right click on the screen and it will zoom out one level. So I'll just back it off a little bit here. So the thing is even though there is, it's kind of should be the same launch power that you'll see it on fiber lengths, but it's not the same for every fiber. So you want to do this process on different cables every time you check. So for example, if this is 12 here on 5000, I wouldn't go to another 5001 just because of losses and other things that may be inherent to the fiber. So I'd always just double check that. I just want to okay. I just wanted to exaggerate it a bit here so you guys could see it, but this is way too far in, but I just wanted to show you. So these amplitudes, like I said, should all be increasing, and I keep my eye on the furthest channels because that's where it affects at the first point. But you can see about down in this area here, when I increase the power, you can see how the amplitudes get all weird, really. They kind of squish and flip around. So that's what it's going to look like. And I'll just exaggerate a bit more here. If I go in, you'll see it doesn't matter how much power I put in, it keeps decreasing, and it will work its way up where these amplitudes start to get affected. So like I said, that's way too far, but so I think I saw it around 9 or so. Let me just check here. Yeah. So I think it happened at around 9 as my attenuation level. So what you want to do too is just back it off a bit and then use the finer adjust and then just kind of creep back to that location that you think it was at, just to see if you can finally tune it. And you may find that it's probably where you thought it was. So now that you have the power set, so here I have it set at 9. This is it's going to stay at for the rest of the acquisition. And then what you want to do is come to each one of these lasers now, and you adjust their detect levels for the photo detector. And like I said before, there's no rule of thumb on this value. What you're trying to do is now get these amplitudes up as high as you can, and each fiber is always going to be different. But really what you want to do is not clip at this 32,000 limit. So here I'm pretty low on the detect, and these amplitudes, this is still fine for this acquisition, but you'll see I can't get the amplitudes higher, but that's okay. If these are incredibly low and your detect is up much lower than this, one thing to look for is it could be a little mini bend somewhere on the fiber, so that's why you want to make it as straight as you can. So you just want to check, and you'll see that sometimes if there is a mini bend, your amplitudes will come right back up again. But this is fine, we're not clipping anywhere, and this is the best we can do. So laser 2, and you can bring it down, but I just type it in here to come down faster, so 15. And sometimes your lasers detect will most likely be around the same level, so you can bring it right down. So I'm just going through and I'm just bringing down the detect for each of the 4 lasers. So you'll see on the front end here, these amplitudes are actually pretty high. It just could be due to a splice. We know that the connector itself was clean because we looked at the OTDR and it wasn't a high front end reflection. But this can be due to splices, just kind of loose over time and all that. But this won't completely damage it, but you can see the amplitude looks flat, and so this is really high reflections. It's not constant, but this is just a drawing error really on this. So what you want to do is, if this amplitude at the front was more like these, you could leave it, but because it's doing this kind of wrapping thing in amplitude, you can use this manage reflections. So just because these are bouncing around, I know it's not a bad reflection at the connector, but what you want to do is manage reflections. You can actually just blank this front part a little bit, and this is where you want to be careful, because we go right directly into OBS2 for the wellhead. So if you blank too much, you're going to go down and get rid of the data that's in there. Your start channel 0, end channel, we'll just say 12. It looks like it's at 10. And you can see it's blanked that, and these amplitudes aren't jumping around as much. So if you have something like that at the front, you want to check, clean it, check the OTDR. If you know that it's good, like I said, it might be a splice somewhere that you can't get at, but you just use this blank to protect it. So now we're optically set up. We know our launch. We have our attenuations done. Now what you want to do too is you can come down and you can say save configuration on the left hand side. And you can say read current configuration. So it's going to pull in all the values that we've set now. And then you can say export configuration. And you can put it into a job folder that you have, but I'm just going to put it onto the desktop right now. We'll just call this Cami test. Or you can put in like 20 kilohertz if you have different settings. I'll put 4 meter gauge. So if the computer resets, but the IU stays on, all of your attenuation settings and everything will be fine. If the IU stays on, if somehow, whatever reason, the computer resets, you don't have to go back through. The IU has it written to it. But if the power cycles on the IU, you'll have to redo the attenuation settings. But because we saved the configuration, you can just go back and reload that configuration, and it will reload those settings again for you. So if I was to start off from scratch, you could come back to your optical setup, just say load configuration, select file, and then you just point to where that one we had just saved. I'm not going to do it now because it's going to redo the lasers and everything, but it will reset it to everything we have. So now we're done with the laser settings. So we want to go back to the connection, and we want to go back to that stream 1 because that's going to be our data type that we would like to acquire. So you say disconnect, and you come to this connection tab when it allows you, and you just say control stream 1, and you say connect. If I'm going too fast too, just let me know. Is it okay so far? It's going to be practice. It seems overwhelming, but you guys will get it. So we're back on control stream 1, and we can now come to configure acquisition. And what you want to do here is click read, because this current software version, you'll notice it selected data type 1 automatically. This is just the bug these guys are going to fix here, but always click read and you'll see it goes back to that data type 37 we have selected. So now we can set our channel number of channels and the decimation. So oh yes, so for this, for the seismic, and when we do any kind of decimation to the data, you will want to put a high cut filter, which is this anti-alias filter you'll see under here. So you just select it. There's only one to select from. And now the decimation right underneath, like I said, we're pinging at 20. We'll decimate by 5. And then I'll just show you. So all this is that this is the data coming directly out of the box, the data rate. So when I say set here, everything coming out of the box is going to be at 4,000 hertz now. And you can actually see up on this little tab here, you'll see your data type, which data type you're in, your ping rate, your decimation, and your number of channels. This is in the optical setup window. But also in that OptaSense, I guess the software's taskbar on the top, you'll see the same thing. It'll tell you your data type, your gauge length, and then your final. So it shows that I'm going from 20 to 4. And this is just to check to make sure you got your right settings. So I'm going to select 5200 channels right now. Okay, it's only let me pick 5,000. So there is going to be a data rate limit as well that it knows on what it's acquiring. But that's okay if it doesn't if it forces you to it. It's better to start off a little bit smaller. So now what I can do is just to check the data. I go to this. You can go to these composite displays. Well overview will give me a waterfall. So you can see, sorry, it's a little awkward on here, but you can see the thing to check for right away too is that here's our data. I haven't adjusted the colors, but on the waterfall display, I can see data's coming in. And on the very bottom, I have a whole bunch of red dead channels. So this is going to take up space, and you don't need that many. So what I would do is just zoom in a bit, and for all of our acquisitions, it's best practice to record maybe a couple of, maybe 5 channels at the end, or 2. And this just allows you to know, or anyone else know, that you've acquired the entire fiber itself. And you can, if you're doing any kind of calibrations to the fiber, you know that you're right at the end channel of that fiber optic length. So if I put my mouse over, it will tell me a channel down here. So this one says 2400. Yeah. So I can see the channel down here where I'm scrolling, and this allows you to just come into here and reset that. You want to, I'm going to take off a couple channels here. Oh no, there's 6 at the end, so that's fine. So you can see there was something, one of the processing chains was already summing channels, so that's why we were like at half when I looked. But now I can see when I mouse over, 4799 is my channel, the last, but these are dead channels. You can see they're red. And you can do a couple past, whatever you guys would like to do as your acquisition. I just want to show you real quickly some things to look for. So this is really good data coming in. So you can see the different connectors at the wellhead splices. I just want to show, so at the end there's a bit of a reflection, but do you see how these channels here where I'm mousing over, they are live channels, but do you see how they're kind of fading in and out? We call it channel fading. And when I told you about if you use smaller gauge lengths, you may not have enough light down there for the system to actually interrogate it. What you want to look for in a bad optical setup, or you might not be able to help it, but if you have this kind of effect but up within your data area, then you know it's either maybe an optical setting, you have to go back. You might, when you get into non-linearity mode and it's way up into your data set, it will look like this where the channels are kind of coming in and out. So there's not enough light down there to resolve it. At the very end of the fiber, that's fine, because it could just be because of this end reflection or what we tried to do to mitigate the end reflection. So that's perfectly fine. But you want to just see if it's up here with any part of your data. But it's not, so this is good. That's what I look for in the data set. So you might have a bit of this kind of white within the blue, but this is really good as long as you're not getting that red. These red here are at each of the splices we have out, so you'll have your surface and wellhead. One thing we do to orient ourselves as well, so we're acquiring right up to the first down slope.
This should be symmetric.
Yeah.
So that blue line to that blue line.
Yeah.
This
and
part's what was missing.
Yeah, I think the last guy. Yeah, I didn't double check that, so blanked it far.
Like that's the top, right?
Yeah, so if you ever have a looped system, yeah, you want to look for that mirrored effect. So the first well, the fiber goes down, loops back up to the very other side of it, and then goes into the next well. And you can see this noise here is actually a mirrored effect of itself, with it being looped in the well bore. Comes up to the next well, loops in, and then it goes out to another splice, and then you guys will have your zigzag surface.
That's between the two wells. So this is OBS 2, that's the link.
Oh yes, yeah, because you have it two fibers in the same well.
50 meters apart or something.
Yeah.
And the OBS 1 is looped.
So I look at this waterfall before I continue on. Like I said, for the optical setup, this data looks really good, so we're happy with this. One last thing for the seismic processing or seismic acquisitions. There's these processing chains. Our manuals talk about them, but if you go to processing settings where this cogwheel is, you can say select processing chain, and we have different ones set up. So when the data comes off the IU, it'll feed through, and we can do our own special workflows. But for the seismic one, you select that. So it's going to just give you a little bit of an error. But if you come back, you want to say view web chain. It's going to ask for an update. We'll just skip that. And you can see the receiver is what's exactly coming off the box. So this is the raw data that's at the 4 kilohertz. If 1 meters was too redundant for your acquisition, some of the stuff we do, we stack even up to 4 channels. So you can come into here, the raw data will go through this chain, but the one thing is that once you record that, it's stuck to the 4 meters. Or you can select, which I'll show you when we set up our recording, you can select the raw data instead. But you can just come here and sum whatever channels, well, not whatever, but these are set here for the acquisition. So this is a view to go through, and like I said, you can come here to decimate it down again. But I just want to show you one more view that is a little easier to see. So if you just follow this chain across, you'll see this one called CBT Publisher. And CBT is just that data format, or there is the ProtaMel, which is the HDF5. And you'll notice, if you're ever wondering which data set you would like to record, it's just good to look at the web chain. Anything that's raw or that just says ProtaMel data, I'll show you a little bit later here, will be what's right off the box, and it will ignore everything in this chain. But if you would like whatever goes through the process chain, just click on the output and it will tell you the name. So these ones are process sensor data. So anything that's processed will be something within this web chain, or sorry, this workflow. But there is an option here for seismic as well. If you come to processing settings and you go to seismic configuration, here you can just visually see a little bit better of your channel summation and your decimation down to whatever milliseconds you're looking at. So here you can't change these, it's just telling you what you are. Processing decimation factor, it has the output in hertz, so we'll just need to know. So we want it down to 1000 hertz. So it's similar, so I can decimate it again, and this is just the software decimation. And then you can also come here to do the summation as well. So this window is just a little bit nicer. Whatever you do here will also update the web chain too. This one's just a little bit more visually pleasing. So you just say apply. So my processed output will be 1000. So we're on the last steps here. So now we just want to come to the OptaSense icon, and in the drop down we'll go to configuration, and then we'll say recorder configuration. It may remember what we selected last time at the shop there. But this is where we're going to write to the disks now, or whatever medium you have plugged in. So all I do is I just come to here. So the F drive is one of the 12 terabytes, and I can add a second one just for redundancy if you would like an A and B copy. So you just say add, and we'll do an A and B. Shouldn't have issues, but it's usually good to have. And then below this is the type of data you would like to record to your medium. So FBE is the frequency band extracted data, which is just going to be what these displays are. They're just going to be for you to just kind of load and visually look at it. But you probably won't need it unless you just wanted to quickly load something for a report for your seismic stuff, just to show something fun. If that's the case, you can select your FBE bands. If you click anything that has a blue hyperlink, there's some additional options you can select. These are just the update rates for what gets displayed when it stores it. I usually just pick full rate because they're pretty small files, but this full rate will be dependent on the FFT size. But I just select this anyways. So because I want the sensor data through that workflow where we have the decimation down to 1000 hertz, I want this process sensor data ProtaMel, and ProtaMel is that HDF5 data set. This CBT is just our kind of raw, like proprietary form, but HDF5 will be the headers you guys can work with. If you wanted no summation or no decimation, just whatever came off the back of the box, like I said, you just pick sensor data, and that will be the raw data off the back of the box. And that's pretty much it. This seg-y one that's here right now, This one is just for some of our microseismic passive recording where you can actually just set a file time interval, and every 10 seconds for this one, it's just going to put out a SegWi file. So you can't really control it or anything. It's just on a time. But we won't select that for this one. We're just going to collect the process sensor data. So like I said, if you were wanting to create some of these waterfall displays quickly, just to load them up in that DXS browser, just as a fun visual thing for a report, I'll just show you one setting where you can go to. So we're going to save because we're just going to record this process sensor data for right now. So if I go back to my seismic configuration under the processing settings, the FBE band configuration is here. So these are the frequency band extracted data. You can set your windows of where you would like to look at the frequencies. And again, this is going to be based on the FFT size. So the resolution will be set by that. For seismic in that, if you're just making displays, I wouldn't really touch these. They're just good the way it is. But you could come in here, and obviously it goes up to, it will only allow you to go up to Nyquist of your sampling. So you can see the software forces it to 500. So it won't allow you to go there. But we won't do that. We won't do it today. So we're pretty much, oh, one last thing, most important thing for seismic. So now I always do this at the very end just to make sure. We have our GPS, so I'll just move this out of the way. So when we connected the antenna, you'll see this, this is the SIU. It just houses some GPS components in there. When you connect your antenna directly to it, you'll see the PPS will go green and the GPS plug-in associated with where you plugged in will go green. This doesn't mean the data's synced. It just means that your antenna is receiving at least something from the satellites. So it's always good to check that you're getting a signal. And then to sync the data, at the very last step here, we go back to the configure acquisition window within our optical setup window where we were doing all these channel changes. And you'll see right over here on the right hand side, it says GPS enable, and then you just say align to PPS. And it's gonna take a minute here, but it will give you a flash. I'll just get rid of these warnings that were popping up. A lot of these warnings are just when we're going through settings, the system just briefly disconnects to the software. So it's always just going to pop up with warnings saying, hey, disconnected. But that's okay because we're setting it up. It'll flash a warning once the data syncs. Another way to check too is on this taskbar at the top is this little satellite. It'll say no sync. You can click this and a little window comes up. And once this does, you'll see this goes green and then PPS will be receiving by the software itself. So the initial first sync takes a little bit. And then once that's ready, we're good to acquire the data. And you just say record, you hit it. And what it's going to do is it's going to auto-populate with a date and time. And then some other name that's just kind of, if you set up your well bore information, here we just had Cami in there. But you could change this, or we could just say record. Is there a name you guys want? Special?
We usually just put the date and...
Yeah, so it'll have date and time. If you do change the time on the computer to any time zone that you're looking for, the software will stay synced, but it doesn't update properly when you change the PC. So all you have to do is just reset the software, and now we can say we're in UTC. So everything's synced, so we can just say record, and then we'll just say record, and there you go. And it's not gonna it's gonna lock everything out, so you can't make any changes to the system until you stop recording.
Show the waterfall at this point?
Yeah, I can do that.
Change the settings.
I'm just gonna delete these. So you can bring up this view. So, when you're on the waterfall, when you bring it up, you can right click on the screen, and those frequency bands that I showed you, you can select through them. But again, depending on the resolution of that FFT, it may not really give you something because it's going to be tight, but 15 to 100 hertz. And also what you can do is when you right click, you come down to properties, and properties will bring up this color bar, and you can just adjust it to adjust your kind of lower and upper thresholds just to make it visually more appealing to see some stuff. I don't think they have it where I can get rid of the right. So the reason why we have 2 on this one is you could, again, depending on the acquisition, have 2 frequency bands you want to look at. If you don't, you can kind of just move your mouse to the center where this gray bar is, and you can just drag it out of the way. And then you can, anywhere there's this like slight gray bar that's hard to see, you can do some movement to readjust the window. And then I always like to just keep, and again it's up to the user, but I keep, whoop, not that. Windows always likes to rescale it. Just below so that I can still see my acquisition settings. They'll never change, but it's just good to see what's going on. And then without a true mouse, it's always hard to get the scrolling to work properly to see the whole view. But we'll put it right here.
Hello, Malcolm. Hello, Malcolm. Excellent question. It's out there somewhere. Not near the wells. I can see them on the trench.
131243.
There it goes.
Stand by, Malcolm. I'll fire you off from here.
So at this scale, I'm not seeing it down the walls,
Yeah,
but I am
it's,
seeing it on the surface between.
yeah, when you extract this one into seg-Y, you'll see that energy. It's a little hard on this waterfall display usually to see the move out down into the well, but
How many meters is Malcolm from the wells? That's the other thing, he might be quite a ways away.
yeah.
This is 13124 Suite 4. Malcolm should be about 250 meters from the well.
That's why.
Yeah. Yeah, the waterfall display won't have that, but when you guys extract into seg-Y, you should see it better on the channel there.
The number on this is 13.
We haven't had good luck with the vibe, that kind of distance or greater from the well.
I can't remember what the furthest offset has been. With,
300 meters.
oh, okay.
By the time he was up to 500, he wasn't seeing much.
Yeah.
You can see him on the trench line, on the horizontal fiber equipment.
Yeah. So this here too is really optical distance. It does say measured depth here or measured here, but in order to get it really into a real world value, you would have to calibrate the channels to a location. But this one's a little harder because it gets funky with the different wells coming in and the different lengths.
Yeah.
So what we normally do when it's in a well bore, we know the deployed end depth. That's why I always display past the end, because that's always reported in the well deviation surveys and all that. So that's one location we can fix it to. And then the second one is the wellhead, where you just go out and you can just tap to the wellhead. And then once you have those two pinned, it will actually anchor you into measured depth.